Hello students, so today in this video we shall understand what is the difference between mass number and atomic mass. These two are very basic chemistry concepts which students are often confused with. So let's start. I will start with mass number. So let's start and try to understand what is mass number. So if you remember the classical model of atom that says that atom is made up of two parts. One is the positively charged nucleus and there is the circular orbits around this nucleus in which electrons revolve. Electrons are negatively charged fundamental particles. Okay, so this nucleus which I wrote here, so this nucleus contains two types of particles. One is proton, one is neutron. Only hydrogen 1H1 is the exception where no neutron is present. Otherwise all the nuclei of all the elements, they contain certain number of neutrons. Anyway, so this nucleus we have, and particles found in nucleus, they are commonly known as nucleons. In combined language we call protons and neutrons are called nucleons. Okay, yeah, so nucleon means either proton or neutron. So mass number is something which is related to total number of neutrons, and in this nucleon the total number of proton present in the nucleus, if we are talking about a particular nucleus, then proton number, that is also known as atomic number, and it is represented often by letter capital G. And the total number of neutron, let's say neutron number in the nucleus, that we represent by letter capital N. So what is mass number? Mass number is related to nucleons. So mass number nothing but it is basically total number of nucleons present in the nucleus. In a nucleus or in the nucleus of an atom, if we are talking about an atom. So this is the total number of nucleons present in the nucleus. So mass number is often represented by letter symbol capital A. So capital A is total number of protons, which is also known as atomic number, that is capital G, plus total number of neutrons, that we represent by letter capital N. So A equals capital Z or capital G plus N. So mass number, as you can see, this is simply the sum of two numbers, and these two will always be a whole number, right? Because number of proton or number of neutron, they can't be fractional, they can't be in like fractional numbers, so they will always be whole numbers. So to mass number is always a whole number, right? So is always a whole number but not equal to 0, because if you are talking about any atom, then it will have at least one proton. So it will be a whole number but it will not start from 0, or you can say it is a like natural number. Anyway, so this is mass number, which is sum of total number of nucleons or total number of proton plus total number of neutron present in the nucleus of an atom. Okay, now let's move to other topic, which is atomic mass. What is atomic mass? So atomic mass of an atom, that is defined relatively, and relative to what? It is defined relative to carbon 12 atom. So atomic mass of an atom, suppose you have an atom, then atomic mass of an atom, that is nothing but you can define it like this: mass of the atom divided by mass of one carbon 12 atom. So I will not go into detail, but this is, as you can see, this is a ratio, so it can be a fractional number, right? So it is atomic mass of an atom, but usually you would have seen that atomic mass is not just mass of one atom, but atomic mass is often dependent on, it is also dependent on isotopes. Isotopes. And what is isotope? So isotopes are, these are atoms or nuclei of same element which have different number of neutrons in their nuclei. So because they are atoms or nuclei of same element, so same element means they will have same atomic number or they will have same G, because identity of atom or nucleus is its atomic number. So if they are same element, that means they will have same atomic number. But as the number of neutrons in their nuclei are different, and you know that mass number is sum of proton plus neutron number, so proton number is same but neutron is different, so mass number will also be different. So for isotopes, I think you know this, for isotopes Z or G is same but mass number A is different, right? And let's take some examples of this isotope. So suppose we take example of hydrogen. So hydrogen is H, and hydrogen is found in three isotopes. It is 1H1, 1H2, 1H3. So 1H1 has number of proton is 1, number of neutron here is 0. In this is first isotope, this is called protium, this is called deuterium, this is called tritium. So these three are hydrogen isotopes, and most abundant isotope in the nature, that is 1H1. This 1H2 is found in little amount, but this 1H3 is very rare actually. It is found in very small amount, and it is radioactive also. So if we talk about number of proton and neutron in these three isotopes, so in 1H2 number of proton is 1, number of neutron is 1. Here number of proton is 1, number of neutron is 2. So you can see here that because they all are hydrogens, so number of proton in all of them are equal, but number of neutron in them are different. That's why their mass numbers are different. These numbers written here, they are the mass number. So mass number of isotopes are different because of different number of neutrons present in the nuclei. Similarly, we can take one more example here, say carbon. So carbon is also found in three major isotopes. One is carbon 12, one is carbon 13, and another is carbon 14. So it is 6C12, 6C13, and 6C14. So this is the most abundant isotope of carbon, and we have just defined the atomic mass of an atom in terms of carbon 12. So this is carbon 12 atom, one carbon 12 atom, relative to which we define the mass of an element or mass of an atom or mass of an isotope, anything. Okay, so 6C12, that is the most abundant carbon isotope found in nature. So carbon, if we talk about number of proton and neutron in these three isotopes, so number of protons are 6 in all of these three isotopes, but number of neutrons are different. In 6C12 it is 6 neutrons, here 7 neutrons, here 8 neutrons. Okay, and 6C14, this is rare and means very small amount. It is in very small amount it is present in nature, and this is also radioactive. And here 1S3, this was also radioactive. These are found in very rare amount actually. Okay, so these are isotopes. So let's come back to our original topic which we wanted to calculate. So atomic mass of an element, as I said, it is dependent on isotopes also. So let's understand it by an example, and let's first discuss the definition. So atomic mass of an element. So if you are talking about atomic mass of a single atom, then it will be the mass of that atom divided by the mass of one carbon 12 atom. It is simple. But if you are talking about atomic mass of an element, and as you know, the element can have multiple types of isotopes, so you have to consider all the isotopes of that element found in nature. So atomic mass of an element, that is defined as the weighted average of masses of all isotopes according to their natural abundance. So you have to consider here natural abundance. What is their natural abundance? Not any artificial abundance. So let's understand it by one example. So suppose we take example of chlorine, and suppose I say chlorine has two isotopes. Actually these two are major isotopes of chlorine. One is chlorine 35, another is chlorine 37. Atomic number of chlorine is 17. So for just simplicity, we are taking these masses as complete whole numbers, but it's not necessary. They can be fractional because they are the relative masses with respect to one carbon 12 atom. So they can be fractional. Just for simplicity, I am taking one isotope has 35 unit of, or unified, U is the unified atomic mass unit, or AMU, atomic mass unit. Okay, so one isotope chlorine 35 that has 35 U of atomic mass, and chlorine 37 has 37 U of atomic mass. And what is their natural abundance? So chlorine 35, that is usually found in 75% abundance, and this is found in 25% abundance. So if you collect chlorine from nature, then you will observe that almost 75% this type of isotope is present, and around 25% this type of isotope is present there. So only these two isotopes are present. So what will be the atomic mass of chlorine? So this will be weighted mass of these two isotopes, because only two isotopes are present. So how will we calculate the weighted average? So suppose you take 100 atoms of chlorine. Suppose you take 100 atoms of chlorine. So in 100 atoms, it is 75% found, it is 25%. So there in 100 atoms of chlorine, there will be 75 atoms of chlorine 35 and 25 atoms of chlorine 37. So what will be the total mass of this 100 atoms? So this will be 75 into 35 plus 25 into 37, and this whole thing divided by 100, because we have to take average, right? Weighted average. So this was the total mass of 100 atoms. So for getting average of that, we need to divide it by 100. And if you solve this 75 into 35 plus 25 into 37, let's calculate this and see what this comes. So 75 into 35, this is 2625. 2625 plus 25 into 37, that will be 925. And this divided by 100. And what will be sum of these two? 925 plus 2625. This is coming 3550 divided by 100. And if you divide the numerator by 100, you will get 35.5 U, and that is the atomic mass of chlorine. You would have noticed this is given in periodic table or in the list of atomic weights or atomic masses of given elements. So you will always say that atomic weight or atomic mass of chlorine is 35.5 U, because you have to consider all the isotopes of that element found in nature. So similarly, you can consider any other element and you can calculate its atomic mass considering its presence of different isotopes according to their natural abundance. And there can be more than two, like there can be 3 isotopes, 4 isotopes. So you have to consider all of them, and you have to calculate the average of all the isotopes according to their natural abundance. So one last thing before going, I would like to tell you that atomic weight and atomic mass, these are same thing. Most often they are used, so you don't differentiate between them. They are almost same thing. Atomic mass or atomic weight, these two are used always in the same sense. Okay, so I hope you enjoyed this video today and you understood what is the difference between mass number and atomic mass, and what is the atomic mass of a single atom, that is defined in terms of relative to one carbon 12 atom, and what is the atomic mass for an element. We defined everything. So I hope you enjoyed this.